Today we take the internet for granted. Need to know something? Do a web search. Need to know if your friend or family is home? Send them an instant message. Need to get documents to the other side of the planet instantly? Scan and email them. This was not always the case. Before Wikipedia, we had to travel to libraries. Before Google, we had to use search cards in libraries or ask somebody to get information. We had to dial a number from memory, or if you're old enough to remember this, ask for the operator to connect you to your friend's house. In this lesson, we are going to look at the history of connecting computers to each other over networks and how that eventually formed the internet and how that led to the World Wide Web. We'll also take a brief look at the risks that come with having everything connected. So what is networking? It is defined as the linking of computers to allow them to operate interactively. But before we start on the history of how networks came to be, let us first cover the very basics. You will learn all about networking in the NET course. So this is a basic overview just to help you understand the concepts that we talk about later when it comes to networks, the internet, and the World Wide Web. So first up is the IP address. So I want you to put on your creative hat and try and imagine the internet as a postal service. Your computer, in this scenario, is your home. In the postal service, every home has an address, and it's usually in a specific format with recipient name, house number, street number or name, city name, state name, country name, and country code. IP addresses, as the name suggests, is the address of your computer or any device on a network. So when you're on a network, the packets can be mailed to the right place because it has the right address. The term packet is used to describe a segment of data sent from one computer or device to another over a network. A packet contains a source, a destination, the data, size, and other useful information that helps the packet make it to the correct location and get reassembled correctly. So in keeping with our postal service theme, the packet is the parcel you receive from, say, Amazon. The parcel contains the items you bought inside, as well as all the relevant data to get to your address on the top, like your address. Now we get to hubs. When referring to a network, a hub is the most basic networking device that connects multiple computers or other network devices together. Unlike a network switch or router, a network hub has no routing tables, IP address, or intelligence built in on where to send information and simply broadcasts all the data across each connection. You can imagine the hub to be the post office in our story. And from hubs, we go to switches. On a network, a switch is a hardware device that filters and forwards network parcels, but usually doesn't do much more than that. A network switch is more advanced than a hub, but not as advanced as a router. Think of a switch as a postal worker sorting packages in a large post office, but on a very high level. So not by exact address, but simply by city or town. And then we get to routing. We're going to continue on our post office story and talk about the city and the state part. In our story, these are public and private networks. So when you get a router from your ISP or you buy one yourself, you go home and you connect your devices to your router. You can now play movies from your computer or server or watch stuff over your TV. This is your private network. But when you browse Amazon, for example, you move from your private network onto a public network, the internet, and then onto Amazon's private network again, where the site is hosted. So the router you travel is from your private network onto a public network and back onto a private network. And to do this, we need something called DNS. When you type in Amazon.com into your computer's web browser, it has to translate that address into its numerical counterpart. This is where the domain name system comes into play. I know some of you might be able to, but most people can't remember long IP addresses for a long period of time. Amazon.com is super easy to remember. DNS is a network of databases that stores records containing which names belongs to which address and allows us to just remember names and not having to memorize numbers. And finally, we get to the internet, Ethernet. It was originally just known as the Alto Aloha network. Ethernet is a widely used LAN or local area network protocol created at Xerox PARC in 1973. Being the first network to provide carrier-sense multiple access collision detection, Ethernet is a fast and reliable network solution that is still widely used today. So in other words, it can send and receive data reliably without the packets colliding with each other and messing up the data. Okay, so now you've gotten a basic understanding of the terminology of networking. So let's talk about the history of networks. Back at the dawn of computing, all computers were really large, heavy machines that often filled entire rooms. So moving them around was a hugely expensive and very impractical task. Even moving disk or storage between devices was impractical due to how fragile and large most storage was at that time. At the best, most workers had a terminal somewhere close to the mainframe, and they could feed commands and receive output from these terminals. In 1961, Leonard Kleinrock wrote a paper called Information Flow in Large Communication Nets. In this paper, he proposed the idea that it should be possible to connect computers to each other via some kind of network. In 1965, Donald Davis coined the term packet to describe data sent between computers on a network. In 1966, the ARPANET, or Advanced Research Projects Agency Network project, was started by the Advanced Research Projects Agency and US governmental agency. ARPA was started in the late 1950s as a response to Soviet scientific progress and the launch of Sputnik. ARPANET was created to make it easier for people to access computers, improve computer equipment, and have more effective communication between various branches of the military. ARPANET started when the first two nodes were established between UCLA and SRI, the Stanford Research Institute, in 1969, followed shortly thereafter by UCSB and the University of Utah. In April 1969, a request for comment document was released that detailed information about computer communications, network protocols, and procedures. The first network switch and interface message processor, or IMP, was sent to UCLA on August 29, 1969. It was used to send the first data transmission on this brand new ARPANET. The internet was officially born when the first data transmission was sent between UCLA and SRI on October 29, 1969 at 10:30 p.m. The first email was sent in 1971. AlohaNet, a UHF wireless packet network, was established in 1971, and it was used in Hawaii to connect the islands together. Although this was not really Wi-Fi, it is the foundation of what we know as Wi-Fi today. Ethernet was developed in 1973 at Xerox PARC. The first international network connection, called SATNet, was deployed in 1973 by ARPA. And then an experimental voice over IP call was made in 1973, officially introducing voice over IP technologies and capabilities. However, the first software allowing users to make voice over IP calls from home was not really available until 1995. The first routers were used at Xerox in 1974, but these were not true IP routers. The creator of these routers called them gateways and not really routers. Then Bob Kahn invented the TCP protocol for networks and developed it in 1978. The Internet Protocol, or IPv4, was officially defined in 1981. This is the first major version of the Internet Protocol that most of us still use. ARPANET finished its transition using TCP in 1983, and the first DNS server was also brought online in 1983. Waveland Technologies, the official precursor to Wi-Fi, was introduced to the open market by AT&T in 1988. Kalpana, a US network hardware company, developed and introduced the first network switch in 1990. ARPANET was also officially decommissioned in February of 1990. And IPv6 was introduced in 1996 as a massive improvement over IPv4, including a much wider range of IP addresses, improved routing, and embedded encryption. And with all these technologies now in place, we found ourselves at the foundation of the internet. And yeah, like I said, this brings us to what we now call the internet. What is the internet? It's a global network that connects various devices via TCP/IP. It is a network exchange that allows for private, public, business, academic, and government networks to connect. We often call the World Wide Web the internet, but they are actually not the same thing. The internet is the global communication system, while the World Wide Web is just one of the services that runs on top of this system. And this brings us to the actual World Wide Web. This was invented by Sir Tim Berners-Lee at CERN in 1989. He was trying to find new ways for scientists to easily share their data from their experiments. Hypertext and the internet already existed at this point, but no one has really thought of a way to use the internet to link one document directly to another document. Sir Tim suggested three main technologies that meant all computers could now understand each other, and these were HTML, the URL, and HTTP. We use all three of these today. HTML is Hypertext Markup Language. This is the publishing format for the web. It includes the ability to format documents and link to other documents and resources over networks. URL, or Uniform Resource Locator, is a kind of address that is unique to each resource on the web. It can be the address of a web page or an image file. And then HTTP, or Hypertext Transfer Protocol, allows HTML documents to be requested and transmitted between browsers and web servers via the internet. And speaking of web servers, this is a computer where files are stored, which can be accessed via the internet using HTTP. Sir Tim also wrote the first web page /editor/browser, the World Wide Web.app, and the first web server, or HTTPD. By the end of 1990, the first web page was served on the open internet, and in 1991, people outside of CERN was invited to join this new web community. Sir Tim moved from CERN to MIT in 1994 and founded the World Wide Web Consortium. It is an international community devoted to developing and maintaining open web standards. He is still the director of this consortium today. The early web community produced some revolutionary ideas that are now spreading far beyond the technology sector. Some of these ideas include decentralization. That means no permission is needed from a central authority to post anything on the web. There is no central node, there is no single point of failure, and there is no kill switch for the entire internet. This implies freedom from censorship and surveillance. We know this is not really true everywhere, but this is the ideal. There's also non-discrimination, which means if I pay to connect to the internet with a certain quality of service, and you pay to connect to the internet with a better quality service, we should both be able to communicate to each other on the same level. This principle of equality is also known as net neutrality. And it also encompasses bottom-up design. So it means instead of code being written and controlled by a small group of experts, it is developed in full view of everyone, encouraging maximum participation and experimentation. The concept of universality is also there. For anyone to be able to publish anything on the web, all computers involved have to speak the same language to each other, no matter what hardware you're using, where they live, or what language or political beliefs they have. In this way, the web breaks down silos while still allowing for the diversity. And obviously consensus. For any standard to work, everyone has to agree to use them. Tim and others achieved this consensus by giving everyone a say in creating the standards through the transparent processes at the W3C. New permutations of these ideas are giving the rise to exciting new approaches in the fields of information, such as open data, open government, open access for education, and free culture concepts. In 2009, Sir Tim established the World Wide Web Foundation. This foundation is an advancement of the open web as a means to build a just and thriving society by connecting everyone, raising people's voices, and enhancing participation. There's something to consider in all this. ARPANET, or the internet, was born in the Cold War, and it led to possibly the most open and free system humanity has ever enjoyed. And even though it's been a long and interesting journey, and it's still full of challenges because there are still people that will try and control aspects of it, we are now able to express ourselves, to freely find information, and even study across the internet and the World Wide Web from nearly anywhere in the world. This brings us to risks. With the expansion of networks and the uptake of always connected devices, people now use the internet for everything, from advertising, for sales, for communication, retailers, studies, payments, shopping, financial transactions. All of this is done over the internet. And due to this, hackers and cyber criminals use the internet as a tool to spread malware, carry out cyber attacks, and simply steal from you. So a new term was born called cybersecurity. Cybersecurity refers to the technologies, processes, and practices designed to protect networks, devices, apps, and data from cyber attacks. Cybersecurity is also known as information technology security. We will only cover a basic overview of this, as it will be covered in great detail in the IIS course. Cybersecurity can be broken down into three types: information security, network security, and application security. Information security aims to protect the user's private information from unauthorized access and/or identity theft. It protects the privacy of data and hardware that handle, store, and transmit that data. Examples of information security include user authentication and cryptography. So, having a username and a password and encrypting things that you send. Network security aims to protect the usability, integrity, and safety of a network, and all associated components and data shared over that network. When a network is secured, potential threats get blocked from entering or spreading on that network. Examples of network security include antivirus and anti-spyware, firewalls, and even VPNs that are used to securely access remote sites. Application security aims to protect software applications from vulnerabilities that often occurs due to flaws in application design, development, installation, upgrade, or maintenance. So you need to make sure if you're an application security expert, that the tools you design, the tools that you roll out, and the systems you maintain are updated in good time, bugs are reported, vulnerabilities are patched, and maintenance is carefully considered. Like I said, you will deep dive into these concepts in IIS and further in your second year. To end this lesson, I thought I'll share some hard-won wisdom from years in IT support. Usually, if there's a network issue, it is nearly always DNS. When you experience internet issues on home networks or any kind of connectivity issues, the issue is usually related to DNS, and that DNS is usually coming from your ISP. So a good tip is to run your own DNS server. If you're up for a fun project, install and run your own Pi-hole DNS at home. You can run the Pi-hole on a container or deploy directly to a supporting operating system easily. It's a very good DNS solution, and it comes with a nice benefit. It blocks ads and other unwanted code from accessing your devices. Here's an example of my Pi-hole setup, and as you can see, it's been blocking things up very nicely. And that brings us to the end of this lesson.